Why am I overexposed? That's the whitest shirt I own. And it's much better, right? Like my face has a proper color now. Anyway, hello and welcome to another Solana tutorial. Today we're gonna talk about errors, specifically Solana Program Errors. And we do that in order to understand when those errors occur such that we can become better programmers. Because let's face it, most of the time that I spend programming is figuring out why something is not working, and usually I have an error, but I don't know where it comes from. And if you have a better connection between this error usually happens when this is the case, then you can more quickly fix your bugs and therefore more quickly write code. So that's the premise of this video. Really, I just want to do something fun today because after all that Metaplex drama, I just don't want to deal with NFTs any standard. So we're just gonna do Solana stuff. We're gonna talk about errors. That's what we're gonna do today. Yes. I'm super excited about this. See, when I was studying computer science in the first semester, we had an exercise where we had to purposely create compiler errors in C. And that was my favorite exercise of them all because I think I learned the most there. When you purposely create errors, you have to think of, well, when does this error occur? And then you have a better understanding of that. So that's what we're gonna do today as well with the Solana Program Errors. We're gonna cause some errors. Oh, I'm looking forward to this. So let's have a look at Solana errors. Here we go. There are quite a lot of them, actually. Maybe we start with an introduction to how errors work. I don't even know what I'm saying here. Maybe one step back first. A program can return okay or an error. Just as a refresher on this thing, right? So if the instruction succeeds, we return the okay in the result, the program result. But if something fails, then we get the error and the error code or error, the type of the error. And this can be any of those, right? So that's a program error for a Solana program. Any of those. And this enum provides us with some common errors, like invalid argument. Pretty generic, but that error should be used when the arguments provided to the program are not what the program expects, so they're invalid. So that can happen in several ways, and then you want to return that error. Or invalid instruction data, or invalid account data, something like that, right? Insufficient funds is a common error, right? If there's not enough Lamports there, we can return this insufficient funds. Or invalid seed, another really good one. And if you want to be more specific than those errors here in this enum, you can do a custom error. The custom error adds another number, so the error code, which then lets you specify it more to your program so that it's custom to your program. Only your program will have this error, right? But every Solana program can return those errors. Now, obviously, we cannot have a look at all of the errors on all the programs, but I do want to have a look at custom errors on the Solana system program, because the system program has their own errors that are only relevant in the system program, like account already in use. That's specific to the system program. Only the system program will ever give you that error code. Well, no, the code can be the same, but for the system program, this error code means account already in use. So the 0 is account already in use. And I'm pretty sure that you've seen this error before. It's a very classic one for when people try to create tokens, but they have already put sol on the address where the token is supposed to be created. Example, somebody might grant themselves a token address and they want this to be the token mint, but then they're like, oh, I'm gonna set this as my key pair and I'm gonna airdrop myself some sol because I need that, right? Because I need sol to... Just gonna quickly transfer myself some sol from another address where I have some, such that I now have 0.5 sol. I have some sol on that address, and if I'm now like SBL token create token on that address, the system program, this one, will tell, this is really a bit too big maybe. It will tell me custom program error 0x0. So it's the first one in the list. An account with the same address already exists. Account address already in use. Because we have sent Lamports there, so the system program claimed this account and is now saying, well, if you want to create an account, which the SPL token create token, the first instruction is a create account, and then the system program will be like, nah, I can't create account because this account is already there. It already has Lamports. What do you want? I can't assign that to the token program. It's already, it's mine. And there we get the 0x0 custom program error of the system program. And the system program has more custom errors, of course, result with negative Lamports. If we were to attempt to send some sol, I don't think that the output is going to be nice of this CLI, but if I were to try to transfer, I don't know, even if I do it to myself, one sol, yeah, here it just says insufficient funds because the CLI already catches that. But cause errors. What did I want to do? Right, send some stuff. So I just sent Lamports. I even just sent one Lamport to anywhere with a new key pair that is not funded. Execute that. Even the simulation will already fail. And it will tell us, well, system program won't do that. There we go. The reason is attempt to debit an account, but found no record of a prior credit. A very common error that I get, because somehow I always try to pay with 0 Lamports. Anyway, but that also doesn't give me the entire... What if I skip pre-flight? Then you send it anyway, and it's gonna fail. But then at least I can look at the logs in Explorer. This is taking... Oh, because it tries to Wait, but it should be able to confirm a failing transaction. Oh no, it won't. Because I can't even pay for that transaction fee. Right? I can't, because I can't pay for that transaction fee, I can't even do this. Right? Because I have a new key pair with 0 sol, obviously. It can't even pump out that transaction. Okay, maybe that's the error for no prior credit. There is just no sol there whatsoever. And here it just failed to confirm this. Fine, so let's create a key pair. And then, yes, sometimes it works, sometimes it doesn't. And now we need to load the key pair, of course. We're gonna load the key pair that does have sol, and we're gonna do a bit more. We're gonna send one entire sol, even though we just have one entire sol, but we also need to pay for transaction fees, so that's just not gonna work. There we go, now I get the thing that I was expecting. There I get my logs, because now it could actually simulate a transaction because I had enough sol on there for the transaction fee. Now we get the insufficient Lamports. We need just 5k more. And the error is custom program error 0x1 from the system program. All ones is the system program. You might also want to remember that. And if we have a look at the errors here, its account does not have enough sol to perform the operation. Result with negative Lamports. That's system program error 0x1. So it is a custom program error from the system program. So 0x0, 0x1. Now, we could go through that list as well. Might as well, because I mean, I'm pretty sure we learned some stuff, especially down here. We will definitely learn something if we get through this. And I'm pretty sure some of them are also in the system program. I could also cause them through the system program, but not all of them. I mean, there are some pretty obvious ones where I just provide the wrong data. You know what? Let's try that as well. So if I were to build this instruction myself, I would go, we have a list of, there we go. If I provide it here, then you get it. Perfect. My public key is a signer and is writable. Any random public key is not a signer, but is still writable. And then we, of course, need the system program ID, which is neither signing nor written to. We call the system program and the buffer. How much do we need? Let's put 16 bytes. 64 has how many bytes? 8, right? Yeah, so it's twice 8. Cool, that works. We manually write big U int 64 with value 2. I think 2 was a transfer. I'm not sure, but I think I sometime learned that. Big int Lamports per sol. I think this is the same as I had it here with the system program. So let's just check if that would do the same. Always good to know what's happening behind the scenes. No, it's not the same, but we managed to get invalid instruction data, which we wanted to get anyway. This was the goal to, well, actually I wanted to get here first, but invalid instruction data is also a good one. We caused another error. In the system program was using the invalid instruction data because obviously some of the data that are provided is not what the system program expects. Now, what does the system program expect? Well, let's have a look at the proper transfer. Wait, I have one more guess. Maybe, first of all, I'm missing the offset here. And secondly, maybe that is too big and it's just 4 bytes and we just write U int 32. And if it's not that, then I need to check. Ha! Yeah, it was that. It was just 4 bytes, the instruction discriminator of the system program, and 2 stands for transfer. Again, we get the insufficient Lamports as we had before. Because we need to pay for transaction fee, we don't have 1 sol anymore, and it fails with 0x1. So that's the custom program error. Result with negative Lamports. Cool. And we've also got the invalid instruction data. Apparently that was, it didn't like that. It got me invalid instruction data. So that was quite easy. Invalid account data. Well, that should also be fairly easy. We just provide, I don't know, a wrong account. Not my key pair, but again, a random key pair. Although then I will already get the invalid signer. Yeah, signature verification fail, that is true. Let's put something else for the system program. Let's not provide the system program. It still tells me insufficient funds and the system program was invoked, at least in the simulation. Even if I leave this out, it somehow puts that into the transaction. And the system program itself doesn't care if the system program is like there or not, right? Can I with a transfer even provide wrong accounts? Because I mean this one, what I could do is set this to false, but I think that is also then a different error. Then it's not a wrong accounts, but it's a writable privilege escalated. Instruction, change the balance of a read-only account. Do you get the type of return data that you... Let's try the simulation again. Okay, that's better. Instruction error. I mean, a debugger would also be good. I'm just doing console logs because I'm a really bad programmer. That's better, we're getting there. So the instruction error, on instruction 0, I assume, there's a read-only Lamport change. That's probably another type of error from the validators, because that can't be a result of a program, but the validators make sure, hey, what this transaction did here is not okay. So there's another level where, what kind of errors are those? Oh man, I thought this would be a fun, quick video. Yeah, well. It's still fun. It's not quick anymore. But we're learning something, so I like it. It's from the runtime, yes. The runtime has this error. At least the runtime throws this error. Where is it? Oh, maybe I want to have a look at those. Oh, there are so many errors that I wanted to have a look at. Can I see what instruction errors there are? Reasons that runtime might have rejected an instruction. So the runtime throws those, which are also good errors to know. Man, I want to go through all of them. So there's a generic error, whatever, just instruction error. Invalid argument, invalid instruction data. So that's still similar to this thing. But this is an instruction error from, wait, what are those? Those are program errors, but there is an implementation for instruction error. So wait, the program error is an instruction error? No, implements the from, so they can be converted. Which way around is it? Oh, my Rust is too rusty. Unwrap or bad code. I love this. Look at that. 0x bad code. Nice. And then it matches anyway to fail here. A valid custom error has no bits set in the upper 32. So an error is a 64 and the custom errors has zeros in the first 32 bytes of bits. And that's why this thing, because that's not 0, will then return me the invalid error anyway. Wow, that's cool. Anyway, so they have a mapping one-to-one, those instruction errors. Some of them can be returned as program error. They're custom. Now I understand this. 0 and then the X. See, whatever you do, as long as you're doing stuff, you learn. That's why I love this. That's why I just want to do a deep dive on errors. I could probably do 4 videos on deep dives on errors. So today is just a dive in until I get so stuck that I want to get out and grab some fresh air again. I don't know. So anyway, let's try and understand this. For any new error added here, equivalent program error and its conversions must also be added. So we know the relationship now. Every instruction error, no, wait. Still. So this is the other way. So a pub key error matches to the program error. This is where from the pub key it becomes a program error. And this is the other way around. From our program error, we get to a instruction error. Let's count them. 54 errors. And the program errors, we only have 19, 20. So not every instruction error is a program error, but every program error is an instruction error. Unsupported syswap, for instance, has a corresponding. So yeah, I think it's that way around. So there are even more instruction errors than there are program errors. Because, I mean, makes sense because the instruction errors, they're raised by the runtime, and the runtime does more checks than a program itself does. Because the runtime needs to also make sure of other things. Like we had here, that we don't write to read-only things and that we don't make up Lamports, right? The program doesn't check that we don't create Lamports out of thin air. The runtime checks that. So the runtime will have a, which one would that be? Change the balance of an executable account, for instance, as well, yes. Instruction left an account with an outstanding borrowed reference. Read-only Lamport change. External account Lamport spent. Right, so if a program would just try to spend Lamports from a different program, so an account that it doesn't own, then the runtime needs to make sure that it's not allowed to do that. So we could go through all of those errors, but then we need to actually write a program to achieve those things. And I will keep that for an upcoming video. I mean, it's super cool. I do want to do this because I think we would learn a lot if we were to do this. But there are 54 of those, and it's like a lot of stuff. Insufficient funds, a classic. Program failed to compile. Okay, that can happen. Max accounts exceeded. Yeah, so cool. This is getting complicated really quickly. So, to recap from what I understand now, we have instruction errors, which the runtime can use to reject an instruction. Program errors that the program itself returns as the result for an instruction, and then the runtime will be like, oh, the program returned that, so I'm gonna use the same error since the instruction failed. The runtime will have the same, right? So if the program returns invalid instruction data as we had it now, then the runtime will say, aha, okay, I will return this invalid instruction data, because there is this mapping instruction error to program error. And in this case, the read-only Lamport change, that is not a program error, that is just an instruction error. Instruction changed the balance of a read-only account. Yes. But the program itself, the system program, doesn't check that. So the system program doesn't return that error, but the runtime checks that. So the runtime then says, this instruction fails because you're not allowed to do that. So there we see the levels of errors, instruction errors that the runtime uses, program errors that then become instruction errors as well, and custom program errors, which are specific to each program. And they will also, of course, result in a instruction error, which will be the custom program error, which is also an instruction error. So there's this mapping also for custom errors. Okay, so to not overload our brains today, like I don't want to go through all of the errors. We've done a few, but let's go through those program errors, because that's what I said in the beginning that I want to do. So custom errors we saw are specific for each program. We saw 2 of the system program. Let's move on with invalid argument error. Still didn't manage to do that. What are arguments provided to a program instruction? Where is that even used? If the account info owner is not the ID. Oh yeah, that makes sense. So invalid argument with the system program, for instance, if I want to send Lamports from an account that is not owned by the system program, like what, a token account? But then also that account would need to sign. If it's signing, that's fine as well, right? So for those things, I think we need to build ourselves a program. We manage the invalid instruction data. An account's data contents was invalid. I mean, that's very generic. You just expect other data to be there. If the proof from bytes, if it can't read that, for instance. Yeah, if for some reason the deserialization of the data doesn't work, we also get the invalid account data. Account did not have the expected program ID is then a owner check failed. An initialize instruction was sent to an account that has already been initialized. Is that the same as this? No. The instruction expected additional account keys. Not enough account keys. Okay, so this one should be fairly easy. Just remove the account keys. Hehe. There we go. Insufficient account keys for instruction. And the exact error in the simulation is an instruction error, not enough account keys. Nice, at least one we managed. An account does not have enough Lamports to be rent exempt. Oh, that's also a simple one. If I were to, for instance, send it to a new key pair, but not send 0. whatever, let's just send 1 Lamport. If I were to send 1 Lamport, then that 1 Lamport is not enough to be rent exempt, and then runtime gonna complain, hey, that's not enough, you can't do that. And that's a new error, by the way, that was added. That's why it's so far down in that list, because the accounts did not have to be rent exempt, but now they have to be. I got a success. And then I still get a transaction. So the system program gives me success, but then transaction simulation still fails because an account, first account, without sufficient funds for rent. And is that the error? Insufficient funds for rent is the error. So that's not account not rent exempt. That's something different again. Damn it! Where does that come from? A transaction error. Okay. I'm finding more errors. Great. There can also be a transaction error. So that is reasons why we might reject a transaction. Again, also by the runtime, I think. Wow, so many errors. Okay, so today is just going to be an overview of all the errors. Well, some of the errors, I'm sure that because there are way more, like every program. And then Anchor has their own errors, and then each program will have their own errors. So we'll just focus on the Solana errors right now. And even there, it's a lot. Account loaded twice. Account not found. Oh, that's the one that I get a lot. That's a transaction error. Attempt to debit an account, but found no record of a prior credit. Account not found. So if I have 0 sol, because the account just isn't there, then that's the error. And that's a transaction error. So it's not on the individual instruction that there's the problem. It's the transaction that causes the problem. And now the naming also makes sense, because why didn't you call them runtime errors? No, because there's still instruction and transaction errors. Different level. Because with those errors, they are just checked on the transaction level. So once for all the instructions. And the instruction errors, they are within one instruction. Within one instruction, I'm not allowed to change the balance of an executable account or invalid instruction data. Obviously an instruction error, because each instruction needs to have valid instruction data. Whereas Blockhash not found, for instance, is a classic transaction error because the instructions don't have the blockhash, the transaction has. So yeah, that's why there's a distinction between transaction errors and instruction errors. But as we see here, an error occurred while processing an instruction. That then makes it a transaction error. So an instruction error is a transaction error. So an instruction error can become instruction error inside the transaction error. So the instruction error, and then we have a U8 and the instruction error. And the U8 represents which instruction it was. So yes, when we had that earlier, somewhere, we had the instruction error 0 and this. So instruction 0 had the read-only Lamport change. And that makes the whole thing a transaction error. Because I'm pretty sure you've seen that before. Error processing instruction, and then the number, and then the error. That's because of this thing. This is a transaction error. Cool stuff. Transaction contains an invalid account reference. That's probably for version transactions when we do lookup tables. Transaction did not pass signature verification. If I provide the wrong signer. Transaction signature verification failure. In the connection. What is that, from a simulation? Skip pre-flight. If I don't simulate and just pump it out to RPC. Nope. Still signature verification failed. Oh wait, the serialize already doesn't work. Hold on. But the serialize I can force require all signatures false and verify signatures also false. Haha. Hehe. Let's do that. I don't care if the signatures are not there. Just send it anyway. But then it will probably not manage to confirm the transaction, obviously. But hey, the fee payer signed, the other guy didn't. Does the fee payer then still need to fee pay? No, probably the fee payer said, I sign this only if the other guy also signs it, so don't send this without the second signature as well. So yeah, this will probably not go through. So I don't really manage to send it out without, I managed to send it, but then I don't have a way to access it. Yeah, trying to make stuff fail is fun and sometimes really hard. I want to get that signature verification failure, but not already here, but like at the cluster. But yeah, playing around with it, the fact alone that I managed to serialize the transaction without all the signatures and without verifying them, that's something I learned in the Solana Pay video. And just, repeating that to do things again, to deepen our knowledge or to make it more, that's a good thing, I think. Transaction expired timeout error. So, yeah. Invalid program. Transaction failed to sanitize accounts offsets correctly. They are very specific, so we need to build the transaction ourselves and then essentially, work on this buffer. I think that's a bit too deep for today. Transactions are currently disabled due to cluster maintenance. Oh, that's also interesting. Also, I have no way of, ever returning that manually or ever getting there. But that's cool. There is a transaction error called cluster maintenance. Yeah, it totally makes sense, right? Hey, cluster is down. But not like down, but we just don't want to process transactions right now down. Transaction borrowing left an account with an outstanding borrowed reference. All executable accounts have no outstanding refs. Don't really understand enough of Rust. Try borrow. Lamports is U128. Maybe the Lamports inside an account is a U64. But yeah, it makes sense that overall there can be more. Actually, that's a good side question. I want to know how many SOL there are. And what better way to do that than to check the coin market cap? That's bright again. Ah. Circulating supply, total supply, max supply, infinite. Oh, cool. We're doing some diving today. Nice. Anyway, so that's the number. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's the amount of Lamports. And now I want to know what power of 2 I need to represent that. 2 to the power of x is this. Which means if I have this and I want x, I need to do a log 2 of this. 58, so 59. Which means a U64 is still enough. 2 to the power of 64 is a bigger number than the thing that I had, because this is 19 zeros and here we had 18. So we are close though, but at least as for now, a U64 is still enough to represent all of the Lamports that exist on Solana. I'm not entirely sure why. Maybe there is the possibility that we go over the U64 and that's why they always calculate U128s for all the sums. Or because accounts could be counted double. No, that also doesn't make sense. Maybe they just wanted to make sure. Maybe the total balances are still in U128, which, you know, makes sense. We don't know how far we inflate that up. But it makes sense to, you know, be sure and have a higher number, right? Then we're set indefinitely with inflation. Okay, interesting to see that internally they use a U128 for Lamport stuff. First time I saw that. Yeah, I'm telling you, just gotta do some stuff and suddenly you find yourself in rabbit holes that you didn't even want to go to, but hey, gotta start somewhere. Starting at program errors, getting to transaction errors. But at some point you also gotta stop digging, and I find that we did learn quite a lot today, because we were digging quite a lot. Address loader errors can also be transaction errors. So yeah, we found 4 levels. Then there's a transport error, 5th layer, because a transport error can be a transaction error. There's an I/O error, or a custom, or we have a transaction error when sending around the packets, if we have an error there. So that's another higher level. You know how validators, you know, exchange. That can just be an I/O error or a transaction error. Yeah. I think I want to leave it here. I think we did good in just getting an overview of all the errors that there are, or some of them, because sure there are more. And we caused a few. I want to leave some room for a future video to cause more of those program errors and system program errors, so custom program errors. To recap, we learned that custom programs are program errors are instruction errors, and instruction errors are transaction errors. Well, I mean, they can be, you can convert them. If there is an instruction error, then there will be a transaction error with that instruction error. So it's not, it is a transaction error, but like that's the way it goes, right? That's, if there is an instruction error, then there will be a transaction error of that instruction error. And this is then ultimately what we see in our simulation. Also like the blockhash not found, a classic one. Let's do that one as the last one. Blockhash is a string? That's weird. See, a blockhash really is just a 32-byte string. So it's a hash. But like, I should be able to set the blockhash to any public key. I'm just gonna create a new one. Or even just my public key to base 58. That should be, from the data length, a block hash. So I should be able to fake that block hash, and then it should tell me that this is not a valid block hash anymore. But it should accept it in a transaction. It should be able to send it out. I mean, the simulation will already fail because the simulation doesn't have the block hash in the recent block hashes. Let's see. I really don't know why I always get this message. I want to get rid of that, but I don't know how. Oh, I'm skipping pre-flight. Yeah, oh, my bad. Transaction was not confirmed. let's not skip pre-flight. Then I should already get the error here. Because a transaction is not executed if the block hash is not among the recent block hashes. There we go. Transaction simulation failed. Block hash not found. And that block hash not found is, as we now know, a transaction error. Failed to send transaction. Result error message. I'd like to go further down. One more rabbit hole before we leave today. RPC request. So the simulation must also already be done at the RPC because we do set the request. Obviously, we locally cannot know the state of Solana, the RPC provider does. So I send my request, RPC does the simulation and sends us the simulation result back if that fails already, unless I specify skip pre-flight. And then that response may have an error. Okay, so we don't get deeper than that in the Web3. That's fine. Let's not dig too much because we do want to edit this as well. Invalid realloc. I mean, there are some good errors, and especially all the transaction errors. It would really be cool to go through all of those. I mean, granted, many of them you will rarely encounter. Some of them you encounter a lot, like, you know, those two, for instance, but those are custom errors of the system program. Some of the transaction errors, like the native transaction errors, block hash not found or already processed. If you send the transaction twice with the same signature, then you get already processed. Oh, we can also do that. That's actually an easy one. So we send and confirm. Don't await this. Say commitment is just processed. Let's cause some errors. Oh, right. Block hash. Of course, we need to put the right block hash again. There we go. Twice the same signature. Interestingly, I did not get... Okay, let's do wait for confirmed. Maybe that was too fast. Interesting. Still too fast. Let's wait for finalized. I want the RPC to already reject it in the simulation because it has already been processed. Otherwise, I mean, the validators will reject it because it will have already been processed. But I still get success back, more or less, from the... There we go. That's better. There we go. The transaction has already been processed. That's a transaction error. Nice. Yeah, so some of them might be familiar. Some of them you might have never heard. Sanitize failure. Transaction failed to sanitize account offsets correctly. Because the libraries that build the transactions do that correctly, we never really see that error. So there's also no real... Unless you go really deep and build your own, like you manually craft the transaction like byte for byte, this is unlikely to happen to you. But yeah, it's good to see where those errors are, what can go wrong, even if we never really encounter it. Then you could be like, aha, so this is the error I'm getting. Where's that actually thrown? And then you're like, in the runtime accounts, okay, let's go there. No, that's probably not what I want. Yeah, serialized size. Otherwise, this is thrown. If the size is larger than the packet data size, then we also throw that sanitize failure. So there you could, you know, read the source code of what are the checks that are being made for this particular error code. But yeah, some of them are just not that relevant. Going back to here. I do want to leave it here though, because it's like, it's too many errors to do all of them. We've done a few. We've done quite a few. We purposely created errors today. I enjoyed this. I learned some stuff, specifically what different types of errors there actually are in Solana. So I hope that you enjoyed this, and I will see you in the next video. You can go check out those, like this video, and subscribe down here. Yes, down there. That's the button. And then I shall see you in the next video. Until then, bye-bye. And create yourselves those errors, just so you learn that if the error occurs when you didn't create it on purpose, you know what to do.